My name is Dwayne Beck. I manage the research farm at Pierre, South Dakota for South Dakota State University. We are located along the Missouri River east of Pierre and have both irrigated and dry land farming operations. The native vegetation is a mixed grass prairie with quite a bit of elevation change in places. The only place that trees grow is in major drainage ways. The Dakota Lakes Research Farm is owned by farmers, both dryland and irrigated. We're 100% low disturbance no-till and have been since 1990. The production enterprise profits are used to support research. The SDSU Dakota Lakes Research Farm hosted our field day virtually in 2020. The link to the videos is below. You can go to the www.dakotalakes.com website and also obtain the link from there. This set of videos has very good discussion of the organic matter and soil structure impacts of long-term rotations that have been going on at the station for as long as 30 years. Crop rotation has been a primary tool for managing agricultural ecosystems from the time that permanent settlement began. Prior to permanent settlement, crops would be grown continuously until the system collapsed, and at that time production was moved to another site, and perennials came back to the abandoned site and restored the soil to a certain extent. These systems are relatively similar to some of those used in Africa to this day, where they actually have a very long rotation containing perennials to restore the soil once they've had an annual farming sequence. Perennials have very deep rooting systems that grow throughout the year and a tremendous amount of diversity. And the deep rooting systems is the real key. Now the key is to mimic in any farming system is to mimic ecosystem processes of water cycles, energy flow, mineral cycle, and community dynamics. Mimic the ones that would be there under natural systems. The perennials help you to go reach down and get the nutrients that are leaching away. We call this catch and release nutrients. And we can do this to a certain extent with cover crops, but more likely we will need to have perennials to fix that problem. The reason we face lots of issues with poor drainage and needing drain tile and things like that is because we've taken perennials out of the systems, in the same way with the salinity thing. If we put perennials in there, it fixes it. Diverse crop rotations can help mimic natural ecosystem processes, like I said. Diverse crop rotation also help prevent resistant biotype, weed, and insect issues, while also improving productivity, ecosystem services, and improving soil properties. In the 1950s, we had technological developments like pesticides, fertilizer, transportation, genetics, etc., that allowed the industry to create linear input-output systems. It's really a mining system. Linear input-output systems degrade the ecosystem and prove to be unstable. Weeds and diseases are nature's way of adding diversity to a system that lacks diversity. So when we go to these low diversity systems, we tend to have more and more weed issues and insect and disease issues. Crop rotations are both more important and more powerful in no-till systems. We need to use them when we no-till, but their ability to help us out is much more powerful because we lack that disturbance that's always messing up natural cycles. No-till is not about lack of tillage, but about managing soil water, soil structure, soil biology, and carbon compounds in the soil. If we do tillage, we really can't do any of those things. I've often used the above slide that I got from Don Lobb years ago in Ontario, where he showed all these different inputs in agriculture that have to be balanced to have a nice uniform wheel. If we take out only tillage and don't change other components to adopt for these changes that lack of tillage brings, and we collapse the wheel. I like to simplify it a little bit and talk about farming system components being cultural practices, technology, and management. So you take all those different things we have there and kind of summarize them in this. The cultural practices are tillage, crop rotation, sanitation, and competition. But as I said before, tillage is a catastrophic event. Tillage is to agriculture what fracking is to petroleum. Both of these increase the speed and extent of removal of compounds from the ecosystem and leave it degraded, which is not acceptable with soils. It might be acceptable to shale and a mile deep in North Dakota. So if we take tillage out, we need to replace it with other cultural practices, not with technology. There's not enough technology available. That's why we have the resistant weeds and those kind of things. Even if it were available, we probably can't afford it, can't afford to use it. And if we could afford it, then we still have to sell it to the consumer. Adequate diversity. Nature's efforts to add diversity can be countered by adding beneficial diversity to the system. There's no need to apply broadcast insecticide to Dakota lakes for the last 17 years or more because of the diversity and our lack of using blanket pesticides. So we have lots of places for the predators to live. Short-term studies are not accurate in evaluating treatments such as tillage or rotation, which have long-term impacts. We have rotations that have been going for 30 years. They didn't really show major differences for the first 10 because we were starting to rebuild the soils after many years of wheat and summer fallow. Now the no-till system was always better than one that would be tilled. These were both no-tilled systems, but good rotations that built organic matter started to walk away from the poorer ones after 10 years became very obvious. Most studies that have been done only have monocultures like corn on corn or wheat on wheat and 2 or 3 year rotations, and we were guilty of this at first, and then we began to use 4 and 5 year rotations in the tests. If you do that, by the time you go through your first system, first turn around the rotation, it's been 5 years, so you have to have a lot of patience in order to do these kind of tests, and you also have to have something like a farmer-owned research center that gives you the time to do that. Granting agencies would not do that. Crop rotation allows time for natural enemies to destroy the pathogens of one crop while unrelated crops are grown. That's Cook and Veseth. We've known that. They got that statement from the 1890s, North Dakota State University. So we have known these things for a long time. We choose to ignore them. I like to think of crop rotations of needing proper intensity. In other words, they can't be too intense or not intense enough. They have to be just right. It's a little bit like a Three Bears thing. Adequate diversity. You can have too much diversity and you lose some profitability if you try to get too diverse. And if you do these things right and get them balanced, then you have stable, sustainable profitability. Native vegetation is the best indicator of the range of intensities which are appropriate for a location. It tells you what Mother Nature wants to do there in terms of water use and how she cycles water. Whenever I travel in the world, the first thing I do is go look at native vegetation. And it pretty well tells me what we can get done. Most of the plant growth problems blamed on no-till are a result of inadequate diversity or improper intensity. If we are doing corn and soybean, which is a 2-crop monoculture anyway, and then we keep that and try to do it no-till, we have neither adequate diversity or adequate intensity. So we need drain tile and we need lots of chemistry. Put the water you save by no-till to work. Make it work catching carbon and putting it in the soil. This catch and release type thing. Use that sunlight to do that for us. More high water use crops and cover crops or double crops at times fit. And some places in South Dakota, they don't fit as well as in others. Eastern part of the state, we have a lot more uh, ability to put in more diversity in terms of double crops and whatever. In the West, we can put in diversity as far as just adding new crops to the system. If I do this right, I reduce my risk. I want to see at least 3 crop types. It doesn't have to be 4. Long intervals of 2 or 4 years are needed to break some disease and weed cycles. If you try to put all 4 in, you'll get 2 broadleaf types in there, and it's harder to mix them because they tend to be more prone to disease issues. Long-term rotation study that we did, cool and warm season crops. We did this out in Lyman County. We had no-till. We used herbicides for weed control, and then after 12 years, Randy Anderson from USDA-ARS came out and planted it all to spring wheat, and he counted the number of weeds per square meter when we used no herbicides. So we're really looking at the long-term impact of these different rotations. We had 15 of them. I'm just going to show you 4. Where we did wheat and chem fallow, we had 31 weeds per square yard or square meters. Wheat, chickpea, 53. Wheat, corn, chickpea, a 3-way rotation. You can take soybeans if you want to there, 13. And where we did a spring wheat, winter wheat, corn, soybean, with these long intervals in there, we had only 3. So that's an incredible weed control without using any herbicides. Can we decrease weed seeds by doing tillage, or what impact is doing some of this vertical tillage stuff or whatever have? Randy did a study tilling to stimulate emergence, or using something like a vertical tillage machine. This was done with a disc. He had green foxtail seed, seeds on the surface, and no-till versus shallow tillage where they were buried 2 inches. You can see the difference in first year, 50 in the tilled system, 50 weeds, % seed that's alive. 20 where they're on the surface, something ate them or they froze or something happened to them. 31 versus 4 the second year, and then when you get that 2-year break in there, you're down to 19 with tilled, but you're way down at 3 with no till. So it's much easier to get weed control in no-till systems because you're not digging up new weed seeds, and the ones that are laying on the surface tend to go away. I often show this photo because it's a wheat field where I pulled in a little wide. It had no herbicide on it, and you can see there's no weeds there. And it's not uncommon for us not to have to spray herbicides on our winter wheat fields. Some experts propose using tillage as a means of addressing weed resistance. I see that all the time. My response is, if tillage was so good at getting rid of weeds, they should all be gone. And what these people propose is to bury the resistant weeds and then start over. But if you start over doing the same thing you were doing before, you're going to get the same impact. And if you continue to do tillage there, then once you did tillage once, you're digging those resistant weeds back up again the next year. Think about what you're doing in terms of weed control. Does the action you take address the weakest point in the life cycle of an organism in terms of weeds and insects? What we tend to do right now is we tend to put post-emerge herbicides on weeds once they're growing. They're surely not as susceptible, and then they can tend to shift their habits to get into sync with what we're doing. This was a photo I took years and years ago when they claimed there was no resistant weeds to pursuit. You notice I put 6 ounces on. There's chickpeas in there if you can find them, and lots of kochia. So there is resistance. I heard the other day somebody say that the water hemp in North Dakota is starting to germinate earlier. Well, it's germinating earlier because they're not growing small grains. If they're growing small grains in there with their corn and beans, then those early germinating water hemps will be wiped out just simply by competition. We tend to try not to do any competition or any tillage because we want to focus on competition. We want to leave our residue in place, and we want to place our fertilizer. So here's our seeder You can see we place our fertilizer 2 inches or 3 inches to the side of the seed so the weeds can't get any. There's full residue cover in between the rows. We're not doing a lot of disturbance with strip till or anything like that. We're doing it all at the same time. And it comes up without really any weed issues because we haven't caused them to grow by disturbing them. And we keep this canopy from last year's crop in place until this year's crop can form a canopy. Is a real big part of what we do. Again, short-term studies are not accurate in evaluating treatments such as tillage or rotation that have long-term impacts. And I said that probably 2 or 3 times. We look at so many studies in the country that are done on very short-term 2 or 3 type rotations at most, or monocultures, and they're done for 5 years. So they really haven't gotten them running yet. Crop rotation allows time for natural enemies to destroy the pathogens in one crop while unrelated crop are growing. Again, same type of thing. That's what we're trying to do. So let's look at how we get there. Rotation principles, both sequence and interval, are important. Sequence is what crop follows which crop, and then how long between that crop coming back again. Because there are sequences like wheat after corn that are just deadly, and you just can't do that because of head scab. And then there are interval impacts. So you need to be a student a bit of these diseases and what causes them and where they come from. Same way with weeds. Crops in the rotation can be antagonistic, competitive, or complementary. So let's look at those terms a little bit. Antagonism is when individual crops or crop types are there that could preclude the production of another. Examples would be mustard and canola. You can't have mustard in your canola, and you can't have canola in your mustard. So you can't grow both of those, you grow one or the other. Cereal rye and winter wheat, which is a big no-to in terms of weed control unless you're going to use some GMO type enhanced wheat variety, not necessarily GMO, but the clear fields and whatever, which have advanced traits. Crops that compete for a place in the rotation, there's a lot of those. We tend to choose one and then just keep focusing on that, but then that leads to buildup of diseases and stuff. Soybeans and sunflower compete for a spot everywhere, especially out here in central South Dakota. Peas, chickpeas, and lentil, you kind of grow one of those, but you don't really grow all of those because they all carry similar diseases. And especially the root diseases, the Aphiformites, will go after all those as well as go after soybeans and alfalfa and things like that, right? So peas and canola provide competition as far as time when you're going to grow them. And corn and sorghum, similarly. So you can think of these as being competitors. They're also have complementarity at times. So 2 or more different things combined in such a way as to enhance and emphasize each other's qualities is where they complement each other. Soybeans and canola complement each other because the root diseases of canola differ from the root diseases of soybean. And canola is deadly on cyst nematodes, for instance. So if you had both soybean and canola in the system, you would reduce certain of these diseases. White mold is shared by both of those. Corn and sorghum. Central South Dakota, especially central South Dakota and more south across wheat country, corn and sorghum coexist and actually complement each other. Sorghum's more drought tolerant. Corn yields more when it's wet. Sorghum breaks the corn rootworm problem in the corn, so you don't have to use as much BT. Sorghum has a nicer stubble to plant into. There's a whole bunch of different things that I have that I can go through if you want me to. Wheat and corn actually complement each other because if you put wheat in a rotation, corn yields better. And there's lots of people that have found that. Randy Anderson is one of them. Peas also complement wheat, which I didn't talk about here, but wheat complements soybeans. So soybeans do better if there's weed in the rotation someplace. Simple rotations. Let's look at rotation types. I have some definitions. We'll explain that, and these complementarity and competition things come in here. Winter wheat, corn, canola, spring wheat, winter wheat, corn, sunflower, winter wheat, corn, pea. These are all legitimate rotations. Corn, soybean, as I said, is a two-crop monoculture. It doesn't have enough residue there. But it's simple. It's a limited number of crops to manage, or 2 or 3 crops. It's very predictable. All the corn is behind the wheat, or all the winter wheat goes into spring wheat. And that's a disadvantage because in a wet year, your wheat stubble may be too wet to plant. And you might need to think of some of those things differently, which we'll get into. Rotations with perennial sequences, which I think we're going to do more of. Here's 2 we now have at the farm. We have 15 years of a rotation of winter wheat, corn, pea. So that goes around 5 times. And then we put it into an alfalfa grass for 5 years. So those rotations swing around once every 20 years. We'll get through that whole thing. And you can see why most granting agencies won't fund a study like that. We have one on irrigation, which is basically winter wheat, corn, soybean rotation that goes around 2 times, and then we have 4 years of alfalfa grass mixture. And in both cases, we're using alfalfa grass mixtures. We're using them for forages, and we will feed that harvested forage on the same fields where it's harvested, so it's not leaving the field. We won't necessarily graze it, but we'll feed it out there. There's lots of other examples. The advantages of the perennial sequences is simple, still smaller number of annual crops to manage the market. It's a great place to spread manure. It can produce more soil structure than annual crops, especially if you have the grass mixture, and it's going to go down and bring your deep nutrients back up, and it's going to fix your low pHs because it's bringing the lime back up. Now, if you take the biomass off of those perennials, it's not going to do that. Difficult to manage sufficient percentage of land in a perennial without grazing, especially if you're doing a forage. You can do grass seed or something like that, but there's limited opportunity. Using less perennial minimizes the impact. Marketing perennial crops is an issue, and especially because selling hay or biomass negates the advantages. I had a young man from Utah come and visit this last summer. His family's farming program was doing 7 years of alfalfa, which was baled and exported to Japan. And then they did 2 years of corn, which they cut for silage and sold to a feedlot, and they got no manure back from that feedlot. And he was hoping to use cover crop between his corn plants to improve his soil health. Well, that's not going to be enough. So we had to have a long talk with him, almost an intervention, I think. Compound rotations, when we start getting a little bit more, remember this sequence and interval thing. In those first rotations, you had very predictable sequence and intervals in every rotation. Combination of 2 more simple rotations in sequence to create a longer, more diverse system. So the one we used to always talk about was spring wheat, winter wheat, corn, soybean. And I called it my mother-in-law or banker rotation because if I look at this, in a dry year, the corn behind the soybean doesn't do very well, but the corn behind the wheat does. So if your mother-in-law or your banker comes in August, you show them the corn behind the wheat. If they come in June, it's more likely that the corn behind the wheat would be struggling a bit at that time because of wet soils, and the corn behind the soybeans would look pretty flashy. Limited number of crops still to manage, creates more than one sequence for some crop types, but we still can't spread the workload like we'd like to. Complex rotations is where we start getting into this complementarity thing. where we change crops within the same crop type. So we use barley and winter wheat instead of two wheats. We have corn and millet or corn and sorghum. We have both sunflower and pea. And that gives us lots of different advantages in terms of diseases and where our roots go in time of planting and those kind of things. Capable of creating a wide array of crop type by sequence combinations, complementarity, in other words, sorghum and corn both in there, or sunflower or pea or canola and soybeans, like I mentioned before. It requires a lot more crop management and marketing skill, and even management in terms of telling some guy where to go to put on chemicals and what chemicals to put on which field, because those are all different. And it confuses the weeds and insects too, which is a good part. Stacked rotations is something we almost stumbled into by accident, and it makes a huge amount of sense. It's rotations where crops within the same crop type are grown twice in succession, followed by this long break, because you saw in the weed thing and the insect thing is the same. The long break is the important part. So an example would be wheat, wheat, corn, corn, soybean, soybean, which we had for a while on our irrigated ground. And then you can make this complex and add both corn and sorghum, or both soybeans and peas. We've done that as well. It's an attempt to keep pest populations diverse or confused, because there's diversity in sequence and interval in every one of the crops. It's a mix of long and short residual herbicides can be used by stacking them together there. If I put milo and corn together, I can put the milo first and use a high rate of atrazine, and then use a Roundup Ready or Liberty Link corn as the second one. And it gives us a mix of this long residual. We do the same thing with a soybean. It reduces the cost and minimizes of the herbicides and minimizes the chance of resistance and biotype changes. There's a 2-year break between corn and wheat, which helps with the fusarium issue. The goal is to allow sufficient time for pest pressure to decline to very low levels before sequencing that crop or crop type 2 times, because it usually takes these weeds. You notice in that weed thing, the first 2 years were very few weeds, and then all of a sudden they explode after a couple of years. So you knock the weed seeds way down, and then you go twice and then get out of there. This example, for instance, has a 4-year break for each crop someplace in there. So at the last wheat and the first wheat are 4 years apart. The last corn and first corn are 4 years apart. So you have that 4-year break, and the same with soybeans. Capable of reducing the risk of developing biotype resistance, can reduce costs for herbicide program. Some crop sequences may not be ideal, especially broadleaf crops, due to white mold risk and some of the epiphymides and things like that. But the real goal here is to get that long break in there. And the goal in any of these rotations should be to be inconsistent in both sequence and interval. One of the things that happened with corn and soybean rotations is we developed biotype resistant insects. In the case of the eastern Dakotas, we have an extended diapause corn rootworm beetle, where the egg doesn't hatch for 2 years, because we were consistent in always having a 1-year break instead of something different. These became the predominant species. In the eastern corn belt, we have biotypes where the female flies from the cornfield to the soybean fields to lay her eggs. If we planted all of our corn into wheat straw out here, we will eventually develop a biotype of corn rootworm that will fly to wheat fields and lay her eggs. So it's just a matter of being smarter than the insect. Rotation utilizing both stacked and normal sequences. Canola, winter wheat, soybean, corn, corn. We have something fairly similar to that goes on in our system. Spring wheat, winter wheat, pea, corn, millet, sunflower. We have guys doing that one. We don't do it quite exactly like that. Winter wheat, sunflower, sorghum, corn, pea is one that we do, where that sunflower is a catch-as-catch-can broadleaf. So more likely for us, it would be soybeans or safflower or something like that. There's no set recipe or best rotation. Individual fields may need differing treatment due to soils, location, proximity, history, landlord, and ownership. You're not going to do some of these rotations that have forages on them if you farm a field 40 miles away, but you need to try to cover all these different things in terms of cycling the water. Different soil types will need different things to cycle the water appropriately. You need to understand the power of rotation, and that is the key. So let's look at some numbers. Our West River rotation study in Lyman County, again, we started it in 1991. So our first usable data was 95. 96, we had a hailstorm. And then we went through 2000 and actually took it out to 2001. But that had another abusive year. So we threw out those years, kept the 5 that were most appropriate. And these are very heavy soils that have been wheat fallow for a long time. So I'm not sure they totally recovered by the time we got here. But alternate year winter wheat, that was winter wheat fallow, winter wheat green fallow, winter wheat oilseed or winter wheat pulse crop was 46.8 bushels, winter wheat corn, and then the same series of alternate crops, fallow, pulse crop, legume, pulse crop, and oilseed. 53, so that 2-year break, you see the value of that. If we're going to be half wheat, which people wanted to be at that time because of farm programs, we're better off to stack the 2 wheats and then do corn and one of these other crops, and that's kind of how we figured out stacking, or part of where we figured that out. And that was 48.4, so you're better off. And then the 3-year break, a 4-year rotation, spring wheat, winter wheat, winter wheat corn, soybean, pea, I guess in this case 57.9. I showed you that one before that was the spring wheat, winter wheat corn, and chickpea. So you look at that, it's obvious. And when we looked at the cost of producing, the cheapest rotation to produce wheat out there was winter wheat, corn, pea. And somebody asked me one time, well, did I make money on peas? And I said it was even a better yielding than the wheat on summer fallow over those 5 years that we used. And somebody said, can you make money on peas? And I said, well, I don't need to make money on peas. I just need to lose less money than it costs you to do summer fallow. So when you start saying I can't make money on something, you've got to think about what all is involved. If you can know only one thing about a soil, what parameter would you want to know? Well, it's organic matter. Within all texture groups, as organic matter increased from 1 to 3%, the available water capacity approximately doubled. When organic matter content increased to 4%, it accounts for more than 60% of the total available water holding capacity. So one of the things we see, and in that virtual field day, we talk a lot about this, and we'll show you the difference between the different rotations. Here's our dryland rotations at Pierre. We started in 1990. After we gone through about 10 years, we saw some rotation, 2 rotations in particular, that really drew apart in tough years and good years. The 2 rotations were corn, pea, winter wheat, and then corn, pea, winter wheat, soybean. So the first rotation is 66% high residue crops like wheat and corn, and only 33% low like pea and soybeans. The second rotation is half high residue, half low residue. So in 2002, we saw it first. That's the one at the bottom. After we'd been there 9 or 10 years, we saw that we had 56 bushel wheat on one side of the road and 28 bushel on the other side. When we'd gotten 6.4 inches of rain in the 12 months from when peas were harvested to when the wheat was harvested. In all cases here, the year before wheat was pea and the year before pea was corn. So there's no difference in those sequences for 3 years. It's just that difference in long-term organic matter. In 2005, the wet year, the middle one, 92 versus 57, and we got 23 inches of rain in that 12 months. And again in 2006, which is a dry year, 60 versus 29. And it was very obvious. When I first saw some of this stuff in 2002, I thought it was a mess up. So we didn't really talk much about it, and then it happened again in 2005, and then in 2006, and it's very obvious. So that's a rotation. This low residue rotation is the one. There's a high residue rotation right across the road. You can see it in an aerial shot. The low residue rotation in the bottom right in the corn pea winter wheat, which isn't a high residue rotation, is in the center left. We have a rotation out there also that's 80% high residue that performs even better than these two. So organic matter makes a difference. It also makes a difference, diversity, in terms of even when you have irrigation, our irrigation ground, we have corn on corn that's been there since 1990. We have a corn soybean that's been there since 1990. We had other corn soybeans there, which we've now gotten rid of, but we've kept one. And then we have a corn, soybean, wheat, soybean rotation that we have used since about 92 or 93. First year soybean in this system behind the corn with no cover crop, no time for it, 76 bushel. Second year soybean, which comes after the wheat, where we have the cover crop, 81.2 bushel on average. This year maybe a little better than that, of course. And then so the corn soybean rotation is 62.9, and the other one averages 78.8. That's a huge difference in yields. And but it's been in corn soybean for a long time. The continuous corn yields on average about 203 bushel, or a bit better now, but this is back a couple of years ago, that at about a 5 or 6 year average. Corn soybean 217 bushel an acre, and then the average of the corn, soybean, wheat, soybeans is 235. Now we have no need for BT corn, rootworm corn in this stuff. We don't, we have a lot less weed issues in there, so we don't have to hammer the weeds so hard when we have that diverse rotation. The continuous corn, if you had 5,000 acres of it, would yield a bit over 1 million bushels of corn and no soybeans and wheat. Corn soybean would give you a little bit over 500,000 bushels of corn and 157,000 bushels of soybeans and no wheat. And that diverse rotation, corn, soybean, wheat, soybean, now if we had 5,000 acres total, there's 2,000 acres of corn, 2,000 acres of soybeans, and 1,000 acres of wheat. We get more total bushels of soybeans on 2,000 acres than we do on 2,500 acres in the corn soybean on average. So that's that difference in yield. It's like having free land. So the 120,000 bushels of wheat is free, right? If I look at that again, does it make sense to trade 72,000 bushels of corn for 120,000 bushels of wheat and 350 bushels of soybeans? And I could do the math on today's numbers. It makes a lot of sense to do that. Because corn is lower priced, even though it's higher than we're used to, it's lower priced by over $1 than wheat. This really struck home, the need for a perennial and those kind of things, when I traveled to Argentina over the years. This is one of the first times I went. They were doing a typical system there that was 7 years of pastures and 7 years of farming. So they would do 7 years of grazing with alfalfa grass mixtures, and then they would do rotations that were wheat, corn, sorghum, and soybeans, and cover crops. So this would be a cover crop on the left, planted after corn, that's going to soybeans, and no cover crop on the right. My good friend Ron Elverson was with me, and we dug up some of that soil and I asked him to model it for me. Notice I didn't take a picture of his face, but look at the soil structure and the health there and the big earthworm and whatever. Well, then the Argentine government, sometime after that, this was in 1996, sometime after that, a year or two after that, they outlawed the export of beef. And so the farmers all quit doing pastures. They quit growing corn. They started just growing continuous soybeans and taking them to port and selling them, because a lot of the land there is rented. And it's a little bit of the situation we have the Corn Belt now. This is what it looked like in 2006. So that was 10 years where they growing pretty much soybeans on soybeans on soybeans, and then they put it into 1 year of corn. So they took me to the cornfield to show me how good it looked. But that's exactly the same field that Ron was standing in when we were there in 1996. Organic matter makes a difference. I think we all know that now. We forgot about it or thought we could forget about it, but we can't. This is what the prairie plants' root systems look like. Those were my daughters when they were much younger, but they're about as tall now as Rika's hasn't changed much since then, the one on the right. Look at the size and the scope of that root system. And where we have our tall grass prairie, we'll find roots that go well beyond 7 feet. And it's just growing all year round. So what you're doing is you're hitting the reset button, so to speak. So with that, I'd encourage you to watch our virtual field day, and I'd also encourage you to go to our website. There's a paper there called Ecosystem Management, Managing Agricultural Ecosystems, that describe these crop rotations and some of the other things that we do. Thank you very much for having me.